Hello everyone, welcome to my math teacher. In this video, I am going to solve question number 1 and 2 from the exercise 4.4. This is for class 10 students from NCERT syllabus. The chapter is Quadratic Equations. Find the nature of the roots of the following quadratic equations. You have to find the nature of the roots. If the real roots exist, find them. So these are the three given quadratic equations. We know that any quadratic equation will have two solutions. So the degree of the quadratic equation indicates the number of solutions. So using quadratic formula, we can find the solutions. That is, x is equal to minus b plus or minus square root of b square minus 4ac by 2a. Okay. When we represent this quadratic equation on a xy plane, we will have a curve like this. This curve is called as parabola. Now the first possibility is the curve will meet the x-axis. This is called as the solution number 1 and the second one. There are two different solutions. That is, it is having two real roots. Okay. Now the second possibility is the parabola will meet the x-axis at only one point like this. Then in this case we have only one real root. Okay. Normally we say it should have two real roots, but the thing is the same root will be repeated. That means it will have two equal roots. Okay. The next one, the third one, the parabola, you can see here, the parabola will never touch the x-axis, which means there is no real root at all. The roots are imaginary. Okay. Now, so how to find the nature of the roots? It's very simple. The nature of roots is called as discriminant. What is this? Discriminant. It is denoted by the capital letter D. You can find the discriminant by calculating like this: b square minus 4ac. As you can see in the quadratic formula, under this radical sign we have b square minus 4ac. So this b square minus 4ac denotes the nature of the roots. If it is positive, then it will have two real roots. If it is exactly equal to 0, that is b square minus 4ac, if it is exactly equal to 0, then it will have only one real root. If it is less than 0, then we will have no real roots, that is the roots are imaginary. To summarize, when the discriminant, what is the discriminant? Discriminant is b square minus 4ac. The value, if it is greater than 0, it will have two real roots. If the discriminant, this value is equal to 0, it will have one real root. If this value is less than 0, then it will have no real roots. Okay. With this information, let us move on to solve the exercise now. This is the first subdivision, 2x square minus 3x plus 5, which is equal to 0. First step is you have to find the nature of the roots. D is equal to b square minus 4ac. Now we have to find a, b and c. A is always the coefficient of x square. In this case it is 2. Okay. Now b is coefficient of x. This is b minus 3. And the last one, c, is the constant. That is 5. Okay. Now let us apply it in the formula now. D is equal to b square, which is minus 3 square minus 4 into a is 2 and c here is 5. Let's simplify this. Minus 3 square is 9 minus 4 2s are 8, 8 5s are 40. 9 minus 40 is minus 31. Now d value is minus 31. It clearly says it is less than 0. The discriminant is less than 0, then this is the possibility. The curve will never meet the x-axis. That is, there is no real roots. The roots are imaginary. So you can write d is less than 0. Therefore, the roots doesn't exist. Or you can write roots are imaginary. Second subdivision, 3x square minus 4 root 3x plus 4 is equal to 0. So let us compare this with the general form. Ax square plus bx plus c is equal to 0. Now we know that a is the coefficient of x square. In this case it is 3, right? 3 here. Now the next one is b. b is the coefficient of x, which is minus 4 root 3. Let us write it here. Okay. Now the last one is c, which is the constant. This is plus 4, which is 4 here. Okay. Let us apply in the formula to find the nature of the roots. D is equal to b square minus 4ac. Discriminant is equal to b square minus 4ac, which is equal to b square minus 4 root 3 the whole square minus 4 into a is 3 and c is 4. Okay. Now you can see minus 4 root 3 square, it will be positive. 4 square is 16 into root 3 square is 3. 16 into 3 is 48. Minus 4 3s are 12. 12 4s are 48. Now we have got d value is 48 minus 48 becomes 0. D value is exactly equal to 0. Okay, this part. Discriminant is exactly equal to 0. We will have one real root. So far we have found only the nature of the roots. Now we have to find the actual solution. How to find the actual solution? Using the formula. Using the formula, x is equal to minus b plus or minus b square minus 4ac by 2a. We know that minus b is minus 4 root 3. So again one minus 4 root 3 inside the bracket plus or minus square root of b square minus 4ac. Already you know the value. The b square minus 4ac, finally we have got this one as 0. Just directly apply it. Divided by 2 into, what is a here? A is 3. Okay. Now which is equal to, minus into minus becomes plus 4 root 3 plus or minus 0. So we need not consider this because it is 0. Divided by 2 3s are 6. Now we can see that 4 and 6 can be simplified by 2. Divided by 2, 2 times 3 times, which is 2 root 3 by 3. Again this can be simplified like this, 2 root 3. 3 can be written as root 3 into root 3. Finally we have got x value is equal to 2 root 3. Okay, this is x value. We can notice here we have got only one real root. Quadratic equation will have the same equal roots. Therefore the roots are 2 by 3, the same for the next as well, 2 by root 3. Okay. The third subdivision, 2x square minus 6x plus 3 is equal to 0. Compare with the general form, ax square plus bx plus c. A here is 2. B here is minus 6. And the last one, 3 is the c value, just 3 here. Now let us apply in the formula. Discriminant is equal to b square minus 4ac, which is equal to b is minus 6 square minus 4 into a here is 2 into c is again 3. 6 square is 36 minus 4 2s are 8, 8 3s are 24, which is 36 minus 24 gives us 12. D value is equal to 12, which is greater than 0. From here you can see this is the first one, first option. Discriminant, if it is greater than 0, then it will be 2 real roots like this. Okay. Now we are going to find the actual roots. Let us find the actual roots using the quadratic formula. X is equal to minus b plus or minus square root of b square minus 4ac by 2a. Here minus b is again minus 6. Okay. So minus, put it inside the bracket, plus or minus square root of b square minus 4ac. Already you have got the final answer. B square minus 4ac, here it is 12. Just apply it, 12 divided by 2 into, what is a here? 2. Okay. Now which is 6 plus or minus square root of 12 by 4. Square root of 12. Let us do the prime factorization to simplify this. 2, 6, 2, 3, again 3, 1. So we can write like this. 2 root 3. 6 plus or minus 2 root 3 divided by 4. Now in the numerator we can take 2 as common. So 2 can be taken as common. It will be 3 plus or minus root 3 divided by 4. So again you can simplify 2 and 4 1 times 2 times. Here it is 3 plus or minus root 3 by 2. Here this is x value. Now finally we have got two clear answers. One is x is equal to 3 plus root 3 by 2 and x is equal to 3 minus root 3 divided by 2. These are the two solutions. The second question. Find the value of k of each of the following quadratic equations so that they have equal roots. As you can see, the variable k is present here and here as well in the second one. Now what is the condition they have given? It contains equal roots. We know that if equal roots means, what is the meaning? Discriminant is equal to 0. What is the actual meaning is b square minus 4ac is equal to 0. Okay, so from this we can write if the roots are equal, then d is equal to 0. That is b square minus 4ac is equal to 0. Now this is a, b and c. Okay, now b square. What is b square? K square minus 4 into, what is a here? 2 into c is the last one, that is 3, which is equal to 0. K square minus, multiply all the numerals. 4 2s are 8, 8 3s are 24, which is equal to 0. Now we have to find the k value. Now transpose this to the other side. K square is equal to 24. Now k is equal to, taking square root, what we will get? K is equal to root 24, that is plus or minus 24. Now we can simplify 24 as well. So using prime factorization, 2, 1, 2, again 2, 6, 2, 3, 3, 1. So we have square numbers. So we have 2 and 2. So let us take this as 2 and this one 2 root 6. 2 root 6 plus or minus 2 root 6. So k is equal to plus, it may be plus 2 root 6 or k value may be minus 2 root 6. These are the possibilities. Now for the second subdivision, let us change this given equation into a quadratic form just by multiplying. Kx into x is kx square minus kx into 2 is 2kx plus 6 is equal to 0. Now we know that this is a and this is b and the last one is c. So again, if the roots are equal, d is equal to 0. That is b square minus 4ac is equal to 0. Now apply b value first. B value is minus 2k the whole square minus 4 into a is here k and c is the last one, which is 6, which is equal to 0. Now multiply. Minus 2k square will be plus 4. 2 square is 4 and k square is, and k will be squared, k square minus, multiply the numerals. 4 6 are 24k, which is equal to 0. From the constants we can take 4 as common. From the variable we can take again k as common. So it is 4k is taken as common. What is left out here? K minus, just you can multiply and check. 4k into k is 4k square minus 6. 4k into 6 is 24k, which is equal to 0. Now you can equate separately. 4k is equal to 0 and k minus 6 is equal to 0. 4k is equal to 0 comma k minus 6 is equal to 0. 4k is equal to 0 means k is equal to 0 by 4. K value is 0 here. Okay. Now here k is equal to 6. Now k is 0. Is it possible? Is not possible. Why not possible? Let us see here. If k is 0 means what happens to this quadratic equation? 0 into x square will become 0 and it will be again 0 here. We will have only 6. If we have only 6 here, then it is definitely not a quadratic equation. That is the reason k is equal to 0 is not at all possible. What is the only left out possibility? That is k value can only be 6 here. Therefore, k is equal to 6 is the possible answer. Hope you must have understood both the sums which I have solved in this video. See you in the next video. Until then, take care. Bye. Keep practicing.